right, so as we look at some of these problems you asked about, and I got some already answered over there on some of the other questions from the video that I did for a couple other students. So I want to try to figure out what is this one going towards. On number 15 was one of the ones you were asking about. As I approach infinity, what's taking place? What I'm noticing here is the degree, and I'm looking at how big the degree of the x to the fourth and the x to the seventh are. And really, in the grand scheme of things, the rest of the stuff really isn't going to, x cubed is pretty high to x to the fourth, but x to the fourth is going to grow the faster than x cubed. So I'm going to ignore the rest of this. And as I refocus this, I have the limit as x goes to infinity of 9x to the fourth over x to the seventh. And when I look at this, the bottom grows a lot faster than the top. And so what's going to end up happening is, if you want to think about it, and we can just reduce here in this standpoint, we can just say, well, this is really just the limit as x goes to infinity of 9 over x cubed. And then now we basically will say, okay, and again, you can't plug in infinity because we don't know what it is, but this is 9 divided by infinity to the third power. So it's 9 divided by something really, really, really big, and so that's just going to work out to be 0, is what that's going to end up being. Looking at 28, and now here's what I would kind of just focus in on is, as we're going to infinity, well, just in general, the limit of as x goes to infinity of just sine x. Well, sine x oscillates back and forth between 1 and -1. And so this one really doesn't have, this limit does not exist. It's not going towards 0. It's not going towards a specific number, just because sine in general oscillates back and forth. So we would say this one, it does not exist. And then you asked about the multiple choice, but there's a lot of them. And so we'll go through and try to talk my way through this. Which of the following functions grows the fastest? So to me, I just looked up from the screen and not even looking at my answer choices. First thing I would say, well, what would grow the fastest? Well, that's when there is a variable as an exponent. That grows the fastest. And then we would look at the base. And then when we had to compare there. So as I look at it, I have 1/2 to the variable power. Okay, so that you could potentially think it grows fast, but the 1/2 is going to trump it. That's just going to get smaller and smaller. That's an exponential decay kind of situation. Here, both the u's are fixed numbers being raised to a fixed, or they are number raised to a fixed power. So they're going to be big, but it's limited on how fast it's going to grow. I really like the 4 to the u. I like that one growing the fastest. So right now I'm going to rank this as my first choice because I have a number bigger than 1 being raised to a variable power. And then as I look at D, it's 200 times e to a variable power. Well, e is 2.718. So, and then I get to multiply that by 200. And so what I really like, and I'm going to highlight in yellow, C and E, I like that first part. That's going to grow pretty fast. The u to the third power really isn't going to help it. It's just the 3 to the u is what you'd want to pay attention to. And then I look at those 3. Those are my 3 I'm looking at because of we have a number bigger than 1 being raised to a variable power. And now I just got to think about, okay, well, who's going to grow the fastest? Well, who's got the biggest base? 4 has got the biggest base. So that one, sorry, I don't know that's popping up. Hold on a second. There we go. So sorry about that. So that is going to be the one that grows the fastest, because if we compare it, 4 to the second is 16, 3 to the second is 9, and then 2.7 to the second, or whatever. It's like 700 and something, or 7 point something. So this one grows the fastest in general, is what ends up happening. Sorry about the screen tweaking on us here. 32, suppose that g of x is equal to that function, and the limit as I approach infinity of the g of x over f of x is 0. So that means that the bottom grows faster than the top, is what that means to me. That f of x has a higher degree than the bottom, than the top. Which of the functions could f be? So we know the top is sine squared x times the square root of x to the 6 plus 4. So I need to make sure that my exponent on the whatever is on the bottom, that function has got to have a bigger degree than what's on the top. And so the 4 is not going to affect stuff much, and so the square root of x to the 6 is really x to the third. And then it's times this sine squared x. And so what I'm thinking it's got to be dx to the fourth is what it ends up having to be, because we need the degree on the bottom to be bigger than the degree on the top in order for us to have it to where that's the case, to where it ends up being 0 as I go out to infinity, because that means the bottom's got to be a bigger degree. 33, which of the following statements are true about the function? Okay, so again, I'm looking at this one. We have a cubic divided by exponential is what I end up having here. So this ends up having a limit that goes to 0. It says, but that doesn't have it to say, has a horizontal asymptote of 1? No. In order for it to be 1, the degrees have to be the same. Here, the bottom grows faster than the top. Has a horizontal asymptote of 1. I like that one. I do like that one. That's a good one. And the reason why I know that is because if I just focus in on x cubed over 2 to the x, and as I take my limit as x approaches infinity, we're going to get a number divided by 2 to a really big number, which means it's going to grow faster eventually. Is what's going to happen. We may not see in the beginning, but eventually, once x becomes a really big number, even if you think about x being 10, that would be a 10 to the third over 2 to the 10th. So that's 1,000 divided by now 2 to the 10th. I don't have a calculator handy. I know that's over 10. That's over 1,028. I think it might be 2,000. Is it or 1024? I think it may be 2048 is what that might be. So that's already bigger. And then if I keep going and say, well, what if x is 1,000? So then we have 1,000 to the third divided by 2 to the 1,000th power. That's when it's going to be a lot bigger. So this is going to work out to be 0. Is what it's going to be. Vertical asymptote at x equals 0. That means that it has to. That 0 makes it undefined in the bottom, and 0 does not make it undefined in the bottom. And so I am thinking on this one that my only answer is going to be B, 2. That middle one, for that horizontal asymptote. Next one, it says, which of the following functions had both a vertical and horizontal? So in order to have a vertical asymptote from a prior lesson, that means that it makes me undefined in the bottom. So I'm looking for a I'm looking for where I got what makes the bottom equal to 0 is what I'm looking at, and then a horizontal asymptote. In order to have a horizontal asymptote, you can either have it be y equals 0, which means the bottom degree is bigger than the top, or the degrees are the same, which gives me like 1 or the ratio of the coefficients. So now I'm going to go off the first part, vertical asymptote. We can eliminate choices. We do not have a vertical asymptote here on the first one because this is 1 over 1 plus 1 over e to the x. So there's no time when we would be dividing by 0 in this case, because as x grows, that becomes 0, so then it just becomes 1 divided by 1. So that's not an answer choice. Tangent x does have a lot of vertical asymptotes, so that does have vertical asymptotes. However, it doesn't have any horizontal asymptotes, because then again, the graph is a bunch of squiggly, like cubic graphs, skipping over whenever it's undefined. So that's not going to be an option there. Let me erase that junk out of there. So it's not going to be that one, even though it had vertical asymptote. There's no horizontals because it always crosses the x-axis. Now, as I look at the next one, this one has a horizontal asymptote at y equals 0 because the degree on the bottom is bigger than the degree on the top. But since it's x squared, there's no chance of the bottom becoming 0. There's no real number that you can plug in for x that you square it and then add 2 to it that you're going to get 0. So that doesn't have any, no vertical asymptotes. So that's not an answer choice. Here's another one that has vertical asymptotes, it has horizontal asymptotes because the degree on the bottom is bigger than the degree on the top. So y equals 0 is the horizontal asymptote. Vertical asymptotes, well, x squared minus 2, I could solve and get x squared equals 2. So plus or minus root 2, those are where my vertical asymptotes are. So this is a potential one looking at it. And then here on the next one, the degree on the numerator is bigger than the degree on the denominator. So this one has no horizontal asymptotes. It does have a vertical asymptote at x equals 0 is what it has here. So to me, D is the best choice here. 35, we got a piecewise function here. Okay, let the function f of x equal this when it's greater than or equal to 0, and that when it's less than or equal to 0, which has the following asymptotes. The function has the following asymptotes. All right, so the top one, let's factor that into an x plus 2 times an x, doofus butt. Oh, goodness. That would be an, that doesn't factor. The bottom factors, so the top stays the way it is, x squared plus 2x plus 3. The bottom becomes an x plus 1 times x minus 1. Which of the following has asymptotes? It doesn't specify, so they want us to think about all the cases here. So the top part has vertical asymptotes at x equals -1 and x equals +1. It has a horizontal asymptote because the degrees are the same. It has a horizontal asymptote at y equals 1. Here, this has a horizontal asymptote at y equals 0 because the bottom grows faster than the top. There are no vertical asymptotes. And so now as I look at what do I have here on that entire function as a whole, we said there's a horizontal asymptote at 0. It has a horizontal asymptote at 1. That's that one. And it has 2 vertical asymptotes at that. So I would go with E being the choice on that one. Is what I would go right that one. That's what I'm. That's where I'm leaning. Can we? The function f of x. So I like the E part. All right, so we don't have to. I guess what here, if we're just, I guess we can eliminate that as a choice, because we're not taking really the limit of it as x approach, because we're not going out to infinity. If we went out to negative infinity. If we're going out so if we look at the bottom one, the limit as x goes to negative infinity, just reading off of the less than 0, as I go out to the left, I get x over e to the x. Well, that becomes like a negative number. A negative, let's say we put it at negative 100, over e to the negative 100, which really, that works out to be negative 100 times e to the 100. And so it's just a really big number. So that part actually doesn't have a horizontal asymptote as we go to the left. So that means I can just, so that means I get to cross off the 0 part. So that's not an answer choice. That's not an answer choice. Now I'm down to those 3. And then I do like y is equal to 1, which they all 3 have. We do know we have vertical asymptotes down here. So that crosses off B. And then now, as we look at it, there's the difference of what about the horizontal asymptote at x equals negative 1? That one there. Well, that x is equal to negative 1 is not in the domain of x greater than or equal to 0. So we don't need to consider that as being an asymptote. So that means C has to be the answer. All right, let's see. One more. I think one more. Well, at least on this one here. Ooh, there's a couple more. Sorry, 37. If f of x is the following function, it has a horizontal asymptote at y equals 2 and a vertical asymptote at x equals 0, then w minus a. Ooh, that's a great question. But then then w minus a is equal to what? Have to think about this one. That one I'm going to have to do a separate video on because I think it's going to take longer to explain that one in this little short period. Let's look at 37 real quick. So as I go out to, we're going to say, what are all the horizontal asymptotes? So let's think about as we go out, as x approaches positive infinity and x approaches negative infinity. As I approach positive infinity, as I take the limit as x approaches positive infinity, we get 2 to the infinity over negative 2 to the infinity, which is just a negative 1. As I approach negative infinity, I have 5 plus 2 to the negative infinity over 1 minus 2 to the negative infinity. So that's really 5 plus 1 over 2 to the infinity over 1 minus 1 over 2 to the infinity. Well, those things just go to 0, so I'm really just left with 5. So what are my horizontal asymptotes? Well, that would be negative 1 and 5.